Hi, I'm going to be showing off my final project. So this is a chatbot. The idea here is there's a few things stored here. There's a TSV file that has a lot of movie lines, like a lot. There's 300,000 in here, I think. So the idea here is you can start this up, you can type something, and it's going to match it to one of these lines. So say I type in, you know, like that good stuff. It'll match with this one, closest one, and it'll spit out the next one, which would be like the reply in the movie. So ideally, it would sound like you're having a like coherent response to what you type. So first off here, there's two CPP files here. There's the main file, read CSV. So quick walkthrough. The code here, it's just going to start, and it's going to make sure you called the arguments properly. So try this read TSV. And it's going to tell you have to put in a couple numbers here. So I'll do 1025. And then it'll start up the program. So yeah, make sure you have the right amount of arguments. It's going to make sure arguments are in bounds. So you can't have like 0, or you can't have like 0 and like negative 100 in here. So read TSV 1025 to start the program. And then this is going to enter the main while loop. So what it's going to do is it's going to get the next line you type. So I'll type hello, and then it's going to give me a response. And I can stop at any time by just typing end, and that'll stop this while loop. So that's the main loop here. So I'll go through a bit of the code here. It's going to start this loop. It's going to make a new line table. This is the class I use to organize the lines in here. So we're going to load the table. So the first thing that happens when you load the table, it's going to, as a parameter, take this line table object. And it's going to be similar to the hash map. We're going to use bins to split up the lines so it can be read through a little bit faster. Here's the slow part that happens when I start the thing is I make a vector of strings for every quote here. Hey, I'm like recording something for my... Sorry. Let's keep like 2 minutes. I'm going to create a vector of strings, and this is going to load in all these lines here. So it's going to load in all the lines to this vector, one by one. And the purpose of this is so we can index it later. Just index all the lines from here. And after that, it runs pretty smoothly. So then it's going to, the number of bins we have, it's going to make this line table. It's going to start adding lines to the table. So the actual line table class here. So line is just going to be each line in here. So it's going to store the actual dialogue. It's going to store the line, like the number, like 1, 2, 3, 4. And it's going to store which bin it's in. And so the line table is going to be, it's going to be pretty simple way of storing information. It's pretty much a vector of vectors. And so each of these vectors is one of the bins chosen. So when we create a new line table, we're going to, then we're going to go over everything in the movie lines vector and add it to the line table. So we're going to table put bin, which bin it should go in, what the index is, and which quote it is. And then once that's done, we have a vector of lines, and then we have a line table which sorted the lines into different bins. So once that's done, then you can get into the main loop here, while run, it'll set this string entry equal to the next thing typed. And if it doesn't end the program, obviously, then it's going to get the closest string out of this table of lines. So line entries, closest, and the closest function is basically the really important part here. So we're going to find which string has the lowest distance in this whole bin. And that's the first number here, sensitivity. So read TSV 1025. The sensitivity of 10 means it has an edit distance of 10 or less. But what we can do is change this threshold. So it's going to say if lowest distance, if it didn't find a line, because it'll find the lowest distance, but if it wasn't below sensitivity, then it's going to actually recurse this function called again with one more depth, and it's going to search the next bin. So that way, you only have to search one, but if you can't find anything there, then you'll search the next one, and then you'll search the next one. And you keep on doing this until you reach the second number, breadth, which is the number of times we're going to recurse and check the next bin. So there's a limitation on that, so this can't run forever. And if it keeps on doing this, it goes through all, say, 25 bins, doesn't find anything that's within sensitivity, it's just going to tell you there's no match. Instead of picking a random one, it'll just tell you to put something else in. So let's just type a few things here. So it's telling us back hi. I'm going to say, how are you doing? And some of it doesn't make a lot of sense. That's because it's matching it to some sort of string, and then it's giving us the response to that string. So it's sometimes hard to see the relationship. So, what's your name? Well, we got a name back, so it's pretty close. Yes, I am alright. Ain't that something? It sure is. Yeah, plenty of money. So you can kind of have a conversation with this. And looks like we're not going to get a match here. Yep. So that's basically how that works. Just end that. One limitation of this is I didn't actually get to implement the splitting by conversations part here. Because we're going by lines, but I wanted to actually split this by conversation, but what happened was, see how these lines are indexed differently? Like line 1045 is on index 1. It just didn't really work out. You couldn't really match them up. So in the end, it really is just reading through this list of lines. So it takes a little bit longer to go through, but it's a similar result, so I'm still pretty happy with it. And that's basically how that works.